Hi guys, it's Mrs. McNeely here. Welcome back. Today we're ready for Module 2, the Real Number System. Make sure that you have your notebook and your paper out. Remember, you're going to need a spiral bound notebook for the course. If you need help getting a notebook, you need to let your teacher know today. We need to get that taken care of this week if possible. Remember, the incentive for you is that you can use your notes on all your quizzes, so you want to have access to those. Here is our agenda for Module 2. I know that it looks like a lot, but we're going to fly through some of these pretty quickly. All right, we want to talk about first the square root of a perfect square. So if you remember last time, we talked about factors of a number. Factors are numbers that a number can be divided by. So if we look at 81, let's find the factors of 81. 81 is 1 and 81. 81 is not divisible by 2. It is divisible by 3, 3 and 27. 81 is not divisible by 4 or 5 or 6 or 7 or 8, but it is divisible by 9. Well, the square root of 81 is telling you to look for some number that multiplies times itself to give 81, and that number is 9. So the square root of 81 is 9, so your answer to this one is 9. Would you please pause the video and try this question on your own? You should have thought about your factors of 16. If you knew your answer right away, you don't need to make a t-chart, but if you don't, then you're going to turn that into 1 times 16, 2 times 8, 3 doesn't go into 16, but 4 does. Ding, 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 there's my perfect square. So the square root of 16 is equal to 4. I want you to notice that we take the little hat shape off when we're done. The square root of 16 is 4. If I write the square root of 4, that's incorrect. The square root of 16 is equal to just 4. Oh, by the way, I should have told you, write this title at the top of your notebook page. I want you to pause the video, make sure that you have these problems written down before you're ready to move on. In the next section of your notebook, I want you to use a calculator to approximate square roots. So I don't know what calculator you're using at home. It might be your phone, it might be an actual calculator, but what you're looking for is a button that looks like this, looks like a divide button. It might be above something else. So on my calculator, there's a button that says x squared, and then above that is a little different colored square root sign. In order to use the square root, I need to hit the second button, and then, which is like yellow in the top left corner of my calculator, and then the x squared. And that will tell my calculator that I actually want to use the square root. If you need some help with that, I want you to find your teacher the next time you're in class and show her your calculator or him your calculator and let them know that you need some help with that. All right, so we want to use our calculator to approximate the square root of 119.5. This says use the Alex calculator, so that may pull up on your screen and you may not have to worry about another calculator. The biggest thing I want to talk to you about today is making sure you're able to round correctly, because Alex will count this wrong if you don't round correctly. So 119.5 is not a perfect square. Every number is not. For example, the square root of 4 is a perfect square because that gives me 2, but the square root of 5 is not. There isn't anything that multiplies by itself to give 5, and it's not 2.5. That's addition. 2.5 plus 2.5 is 5. So that's what I need to use my calculator to approximate. So I'm going to put in 119.5 for the square root, and that's going to give me, notice I take the little hat off, that gives me 10.931605555. But I don't want all these numbers, that's not convenient. I want to round to the nearest hundredth place. The hundredth place is your second decimal place, so not the 9, but the 3. We look to the right. Anything that's 4 or below tells me to keep that number the same. Anything that's 5 or higher tells me to round up. So in this case, I'm going to keep the 3 the same and take everything else off. So my answer should be 10.93. You pause the video and try this next one on your own. Welcome back. 152 is not a perfect square, so you should have put this into your calculator. So when I put this into my calculator, I get 12.32882801, and it again says round to the nearest hundredth. The hundredth is the second decimal place. I look to the right, the 8 is above 4, so it tells me to round the 2 up to a 3, and everything else drops off, so this becomes 12.33. Again, if you don't round correctly, Alex will count these wrong, so as you're doing them, if you think you had them right and you did it correctly, check your rounding. All right, at the top of your paper, I want you to identify numbers as integers or non-integers. Make sure you've written that title down. And I want you to write down for yourself what integers include. Integers include the positive and negative whole numbers, no fractions, decimals, or symbols like pi. Pause the video if you need to and write that down now so that you have it to refer to later when you're doing your practice problems and when you're doing your quiz. So essentially we're just saying yes or no here. A fraction is not going to be a whole number unless there's a 1 on the bottom. So no, that is not an integer. We want to be careful about one like this. -2 divided by 2 is -1. -1 is a negative whole number, so we would say yes for that one. -96.67 is a decimal, and I should have shown you that we're circling these in here, is a decimal, so it is not an integer. -85 is a negative whole number, so we would say yes. And 38 is a positive whole number, so we would say yes. You pause the video and try this problem on your own. You should have said no, because that does not reduce to a whole number. Yes for 56. Yes for -18/2, because that reduces to -9. Yes for -36/9, because that reduces to -4. And no, because that's a decimal. All right, I want you to write at the top of your next section, identifying rational numbers as decimals. And then you want to write down rational numbers are numbers that could be written as a fraction. Decimals that can be written as a fraction either repeat or terminate. Both of these things need to be written down now. So pause the video if you need to write those. You want those in front of you when you're trying to do these later on your own. All right, so I'm going to actually start with the reason instead. Is this a terminating decimal? No, it's not, so we don't want to put that there. Is this a repeating decimal? Yes. As soon as we say it's a repeating decimal, then we know that it can be written as a fraction. Let's try this one. Is this a terminating decimal? No. Is this a repeating decimal? Yes. Again, that means yes, it can be written as a fraction. Is this a terminating decimal? No. The 3 dots, it tells me it keeps going. Is it repeating? No, there's no pattern. This is a decimal that neither terminates nor repeats, so we would say no to that one. For this one, is this a terminating decimal? Yes, the 3 dots don't continue to go on forever, so we would say yes, that can be written as a fraction. Would you please pause the video and try this one on your own, and then we'll go over it together. So you should have said that yes, this is a terminating decimal, so yes, it can be written as a fraction. For 0.8 repeating, you should have said it's a repeating decimal, so yes, it can be written as a fraction. For 0.4 repeating, you should have said yes, this is a repeating decimal, so yes, it can be written as a fraction. Only the last one is no. It's a decimal that neither terminates or repeats, so no, it could not be written as a fraction, therefore it would not be rational. All right, top of the next section, I want you to write rational and irrational numbers. Rational numbers are numbers that can be written as a fraction. So we were working our way up to that on the last section. So I want you to write this down for yourself. Rational numbers are numbers that can be written as a fraction, and you might want to make a list for yourself. Whole numbers, integers, perfect squares, and repeating and terminating decimals are all rational. Irrational numbers cannot be written as a fraction. Numbers with symbols like pi are always irrational, and square roots of non-perfect squares are irrational. So let's try this first one together. 13 pi is going to be irrational. As soon as I see pi, I'm going to mark irrational every time. Square root of 81 is rational because the square root of 81 is 9, so this answer would actually be -9. That's an integer, which means it's rational. Integers are always rational. This is a terminating decimal. Terminating decimal. Terminating decimals are always rational. Now, unlike the square root of 81, the square root of 3 does not turn out to be a perfect square, so it's irrational. And this is like what we were working on in the last section. That is a repeating decimal, which means it could be written as a fraction, which means it is rational. All right, I want you to pause the video now and try the next section on your own. See if you can figure out why each one is rational or irrational, even if you don't say it out loud. See if you can think about it to yourself. All right, welcome back. You should have said that the square root of 14 was irrational because it's not a perfect square. You should have said that 90.67 repeating is rational because it can be written as a fraction. You should have said that negative 11 pi is irrational because it has pi with it. You should have written that the square root of 1 is rational. The square root of 1 is just 1 because 1 times 1 is 1, so that makes it rational because it's a perfect square. And negative 1.61 is a terminating decimal, so it's rational there. All right, next section, constructing a Venn diagram to classify rational numbers. We're going to be doing several Venn diagrams. You don't need to make a new title every time. In fact, if you want to just title this, constructing a Venn diagram to classify rational and irrational numbers, that way this will sum up all the Venn diagrams that we're doing. So the question will look like this, and it's going to ask you to sort of drag these over and drop. So when you're working on Alex, these will be things that you can pick up and move. The whole numbers are our smallest set. They are only the positive whole numbers. Integers include the whole numbers. So they're the positive whole numbers, but integers are also the negative whole numbers as well. And then both of these things are special types of rational numbers. Rational numbers out here would be things like fractions, decimals, anything that can be written as a fraction but isn't an integer or a whole number. So let's see if we can place some of these things now that we look at our labels. So 12. 12 is a positive whole number, so it goes inside the blue circle. 28 is also a positive whole number, so it goes inside the blue circle. 4/5 is not an integer or a whole number, but it is rational because we can write it as a fraction, so it goes on the outside. And again, you would just drag and drop these over if you were working on Alex. Negative 7.06 repeating is rational because it's a repeating decimal, so it goes out here, but it's not an integer. It's not special enough to be an integer or a whole number. And negative 42 is an integer. It's not special enough to be a whole number because it's negative, but it is special enough to be an integer. I want you to notice that your whole numbers are also integers. Your whole numbers and integers are rational numbers. So that's going to be important later on. Let's try another one. So we've got our Venn diagram here. This time I want you to draw this and let's see if you can label it on your own. So draw a big rectangle and then a circle and a smaller circle on the inside. And let's start just by labeling with these three words. Go ahead and pause the video and see if you can do that now. Welcome back. You should have said that the outside green box was your rational numbers. And then the purple represents your integers. And the blue represents your whole numbers. All right, pause the video now and see if you can put these numbers in the circles where they go. You should have put 3.07 with the rational numbers, negative 37 with the integers, negative 15 with the integers, 20 with the whole numbers because it's positive, and negative 1/8 with your rational numbers. If you don't have all that written down, I want you to pause the video and do that now so that you have this to reference when you do your quiz later. Now we want to use this to describe some relationships. So again, this is the same as always. The outside box is always your rational numbers. Your whole numbers is your smallest set. That's only your positive whole numbers. Integers are your purple circle here. Let's do some true or false. Are there rational numbers that are not integers? Well, yes, anything that's out here. So 1/2 would be a rational number that's not an integer. There is space outside of that purple circle for rational numbers, so we would put true. All rational numbers are whole numbers. No, that's not true. Integers are not whole numbers. 1/2 is not a whole number. The only thing that's a whole number would be something like +5. So all rational numbers are not whole numbers. All integers are whole numbers. No, -3 is not a whole number, so we would say that's false. And all integers are rational numbers. Yes, anything that fits inside this purple circle is also inside the green box. -3 and 5 are both rational numbers, so we would say that's true there. All right, you pause the video and try this next on your own. You should have said that your green box was your rational numbers, that your purple box was your integers, and your blue box was your whole numbers. And notice that when I did this one on my own, I put in some sample numbers to help me answer these questions. So the first question said there are rational numbers that are not integers. We already answered that one over here. Rational numbers, there are rational numbers that are not integers, so that's true. Are all rational numbers whole numbers? No, a number like 6 is rational, but a number like 1/2 is also rational, but it's not a whole number. Are all integers whole numbers? Nope, a number like -5 would not be a whole number, so all integers are not whole numbers. Are all integers rational numbers? Yes, they are. That purple circle fits inside the green box, so we say that's true there. All right, now, we have so far only talked about the rational number world. Rational numbers include the integers and the whole numbers. But if you remember, I asked you some questions about irrational numbers. They fit in a different world. Rational and irrational numbers are both real. They're not fake. You're going to learn about fake numbers later on. We call those imaginary numbers. But for right now, we're going to talk about the two types of real numbers, rational or irrational. So let's see if we can place these. 7.3 is rational. It's a terminating decimal. -23 is an integer. It is a negative whole number. The square root of 64, that's a perfect square. The square root of 64 is actually +8, so that goes in with our whole numbers. -87 is an integer, but here's why we need a new category. Anything that has pi, anything that can't be written as a fraction, which pi cannot, is irrational, so it goes over here in our irrational number world. Make sure you have this box written down before we move on, and you have it all labeled so that you have it ready to look at before you do your quiz today. All right, go ahead and draw your box, see if you can get it labeled, and see if you can assign these to the categories they go in. Welcome back. You should have said that this was rational. You should have said that this was irrational. And then these are your integers, and these are your whole numbers. You should have put 96 in with the whole numbers. Square root of 21 is not rational because it's not a perfect square. So we put that, even though -5, it's kind of like pi. If there's an irrational number in there somewhere, then we can't count it as rational, even though there's a -5. So -5 times the square root of 21 is irrational. 0.2 repeating is rational, but it's not an integer or a whole number. 16 pi, because it has that pi, it's automatically irrational. And the square root of 36 is a negative whole number, so we're going to put that here. The negative square root of 36 is the same thing as -6, so it's an integer. All right, now let's describe some sets here. You should have noticed that we now have both rational and irrational numbers in the real number world. Inside the rational numbers, there are some special types, integers, which are the positive and negative whole numbers, and whole numbers, which are only the positive whole numbers. So the first question asks, some integers are not irrational numbers. So some integers are not irrational numbers. Well, I would say that's false. All integers are not irrational numbers. Some whole numbers are irrational numbers. Well, I would also say that's false. There are no whole numbers that are also irrational numbers. All the whole numbers fit over here in the rational world. Some integers are not whole numbers. So we're looking at integers. Are there some integers that are not whole numbers, like -6? That's true. And all whole numbers are rational numbers. Yes, the blue circle fits inside the green box always, so we would say that that's true. Make sure you have this written down with these statements before we move on. Pause the video and try filling this one out all on your own. Welcome back. Obviously, you should have said by now that this is rational, this is irrational, this is the integers, this is the whole numbers. Some irrational numbers are whole numbers. That's false. There are no irrational numbers that are whole numbers. All the irrational numbers are separate from everything else. All rational numbers are integers. That's false, because there are numbers out here like 1/2 and 3.6 repeating that are not integers. All integers are whole numbers. That's also false. If I had -7, -7 is an integer, but it's not a whole number. And no integers are irrational numbers. That is true. The integers are completely separate from the irrational numbers. All right, you're done. This video is available on Haiku if you need to rewatch, and will be available in each skill for Module 2 in ALEX. You now need to go to ALEX and complete your Module 2 practice problems. Don't forget that if you have a question, there is a tab for explanation on every problem that you can see, and then it'll just give you a different problem to solve when you're done. When you're done with Module 2, you need to take Quiz 2. So again, the circle with the lines in the upper left-hand corner, and then your assignments, and you'll be looking for Quiz 2 to take for this. And that's it. Hope you guys have a great rest of your day.